record now. Okay. So now that we know what we're plotting on the x and y axis, well, axis. Let me see if I could zoom out here. Okay, it's not letting me zoom out. But anyways, so for the physics students, you might know this. People who already did graphs, I hope you know this. The scale goes in this corner right here. So you have like scale, and you'll see what's the scale for the x, what's the scale for the y. You're going to have your little graph. So I can zoom out. So I'm gonna just show you what your graph will look like. So you have your y values here, you have your x values here. The graph will look like a straight line, y a straight line. The line of best fit, right? So say I have some points here, 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 here. Oh gosh, no. It's the mascara right here. No, none of that. Here, here, here. I'm gonna show you those points. So like I said, for these physics students, I feel like this would be very easy for you to do.
Then you just draw a straight line.
Yeah. The non-physics students, it's still okay though. I'm sure you could pull this off.
Don't have to connect the x, just draw a straight line.
Yeah.
Just don't care about the x.
So line of best fit, the line doesn't necessarily have to pass through all the points, but it must be logical, right? So that is what, if my points look like that, that's what the best fit line would look like. But I cannot go and do, okay, that's what the line should look like, right? I can't go and draw my line like this. That don't make any sense, right? That is not a line of best fit. Because what I'm doing with all these points on this side, that not making any sense. That's not my line of best fit. What you should aim to do, if you can't get the line to pass through the point, you should aim to have an even number of points on both sides, right? So you see how I have 2 points here and 1 point here, that's fine. But I cannot have, gosh, so if I have like 1 point on one side and 2 points on the other side, that's fine. But if I have my line looking like this, that's not making any sense, okay? That's not a line of best fit. That's just a line, okay? They want line of best fit. You're not going to get you're not going to get the line to pass through all the points. That's why I call a line of best fit, okay? Everybody good so far?
Yes, miss.
Just trees.
Yes, miss.
Okay, well, that's how your graph is going to look. That's what it's going to look like. So not exactly like this, right? But close to it. And I suggest that you draw this graph by yourself, right? I feel like the physics students would know this. You see, knowing how to plot a graph and actually sitting down and plotting a graph by yourself, two completely different things. You would know, okay, I need to have my scale, appropriate scale, y x-axis, line of best fit. Okay, you would know all of that, and you go into your exam or your test or something, and then when it's time to actually sit down and draw the graph, because you did not practice before, you know what to do, but then you don't understand why you can't do it. If I knew what to do, why am I unable to plot this graph? That's why it's very important to practice. Physics students would know this. You have a graph in every exam. You need to practice drawing those graphs. You can't just, know what to do and then hope for the best. you need to practice drawing those graphs, right? So I suggest you actually do this graph, plot the graph, show it to me. I'll tell you what's up. You know? Right. Don't just say, okay, I know how to plot a graph. Let me go into that exam room and, you know, look for the mess. No, none of that. Okay. So just now, let me just get the okay. So everybody understand what I was saying about actually practicing to plot the graph and not just, you know, knowing what to do? Yes, no?
Yes, miss.
What do you say, miss?
You have to actually sit down and practice plotting graphs and not just, you know.
Yes, miss.
Miss graph easy. Unlike other maths have so much step, miss.
You say it's easy because you do physics. Somebody who doesn't do physics might not think this is very easy.
You just need a y-axis. You just need a what, title, scale, y-axis and x-axis. Then
Yeah, because you do physics, like,
no,
this
miss.
is the nature.
You learn that in maths, miss. You learn that in what? First form, miss. I think.
Okay. Practice, just to practice, right? So we said this was y, log of p was y, log of x was x. So they asked me to find the constants. So there's part 3, right? This part. They asked me to find the constants a and k. How would you do that? Can anybody tell me? We went through something similar to this. How would you find k and a? Oh, by the way, they said hence, right? What does that mean? They want you to actually use this graph that you got. So say the graph look like that. They want you to use this graph to determine k and a. Maybe it wouldn't look like that. It would look like this. They want you to use the graph to identify what k and what a is. Anybody has any idea what we would do to find k and a? Going once.
But what, miss?
How would you find k and a? Or a and k?
Miss, to find k, you can take 2 points on the line because since it's the gradient.
Exactly. Good job. K is my, well, k is not my gradient. Minus k is my gradient. But if we have minus k, then we can find what k is. So that's not a problem. Yes. You would take 2 points on your line. That's how we find the gradient. You take, You take 2 points on your line. So 1 to the bottom and then 1 all the way to the top. And you find the, major axis. And you use the formula. We know formula for gradient. M equal to y2 minus y1 over x2 minus x1. So say this y value, I would say this is y2. This is x2, x1, y1. And all I do is substitute those values into my equation to find the gradient. Why am I finding the gradient? Because that's why I was practicing with you how to identify y, m, x, and c. I would be able to tell that. Hold on. I would be able to tell that minus k in this case is gradient of my graph. So by finding 2 points in the graph, so just having 2 points in the graph and then using this formula to find gradient, I would be able to find minus k. And if I had minus k, well, I would be able to find out what k is. Okay. Everybody following what I was saying so far?
Yes, miss.
Yes, yes.
Okay. A. So I already established that minus k is my gradient. So if I have minus k, I'll be able to tell what k is, right? How would I find A though? Anybody has any idea?
A is the y-intercept. So you'll see where the line intercepts on the y-axis.
This is C. Is my y-intercept, so log of if you catch it though. So say I sketch my graph, graph looking nice and all that. And I get this to be 2.7. So it's my, oh my gosh. That's my y-intercept, right? Y-intercept is wherever the line cuts the y-axis, right? So it'll be that point there, and say we got that value to be 2.7. They want me to find A, the value of A, right? 2.7 is not the value of A. Log of A is equal to 2.7. You understand what I'm saying?
Yes, miss.
We said C is log of A. C is also known as my y-intercept. We did that when doing coordinate geometry. So C is my y-intercept. I found out by looking at my graph that the value of the y-intercept is 2.7. So what does that mean to me? If log of A is my y-intercept, and I found out that that value is 2.7, that means that log of A has to be equal to 2.7. However, they didn't ask me for log of A. They asked me for the value of A. So what do? Well, you use your rules, and you would know that A would be equal to 10 to the power of 2.7. Everybody go with that?
Yes, miss.
Yes, miss.
Okay. Nice. Okay. And how many marks is that? 7 marks. Oh gosh. What is this? Yeah, 7 marks. Question 1. So, how was that? You following? Okay.
Yes, miss. Just needs to practice more.
Yes, that's very, very important. Practice, 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 practice. Remember to sketch that graph. Not sketch. Plot that graph. I would do you could stop the recording now.